Good morning, my algebra students. Today I'm going to show you how to get to the quadratic formula using completing the square with the quadratic equation. Now below here I have the quadratic equation, right? And normally we would say y equals ax squared plus bx plus c. But remember, we want to solve when it equals 0, right? So we are going to go ahead, usually we would say when this equals y, but we're doing it when it equals 0 because we want to complete the square solving for our roots or our x's, right? But what happens when you can't complete the square? Like something is just not quite right, like if you have a decimal or something. So we're going to work through that and show you that you can solve using the quadratic formula. And how we come about with the quadratic formula is completing the square just using this equation, right? Just using this equation. So let me show you how this works. First, I need to isolate my x squared. So I would divide everything by the a value, right? Divide by a. And I divide everything by a on both sides, right? So I get x squared, and these obviously would cancel out here, right? And then I have b divided by ax plus c over a, and that equals 0 still, because 0 divided by a is just 0, right? Now, to complete the square, I need to make room for it. So I subtract my value of c, which is c divided by a, from both sides. All right, got to make room for completing my square. Now that I have room for it, I'm going to take my middle term and I would cut that in half and I would square it, right? I'm just going to complete the square like I normally would. So I cut that in half and I square it, right? Here I would cut it in half and then I would square it. That's why this is 1/2, right? 1/2. Just want to clarify that for you. All right. And I add it to both sides. Now, I made this perfect trinomial square, so I know what it is. It's x plus b over 2a squared equals my other side of my equation. Now I'm going to go ahead and square these, so I'll get b squared. I'm distributing my my exponent of 2, so I'll get over 4a squared, right? Now I want to add these up. I need to simplify this value over here, and I can do that because it's just adding fractions, right? It's just adding fractions. Let me show you down here what that means. I get my common denominator. How can I do that? I get the common denominator of 4a squared, right? Which means on the top number, I need to multiply by 4 and an a, right? What I do the bottom, I do the top. And now I am combining my terms on top here and on top here, because now I have a lowest common denominator. And when I do that, I get b squared minus 4ac all over 4a squared, right? Okay, and that's how I got that. Now, to complete the square, I square root both sides, right? I square root both sides. That gives me x plus b over 2a equals plus or minus, right? The square root of b squared minus 4ac. And then when I look at 4a squared at the bottom, I can square root that, right? I can square 4 and I can square root a squared. So I can simplify that to be 2a. but it's no longer in the root bar anymore. What makes this super handy, when I square root that and get it all over 2a, when I subtract the b over 2a, they already have a common denominator, right, of 2a. So I get negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, because I have a common denominator here, I can combine this a bit and have my final quadratic formula equals x equals the negative b plus or minus the square root of b squared minus 4ac all over 2a, all over 2a. Now, I know that is a lot to swallow, but I'm not asking you to memorize this. I just want you to know we didn't just pull this formula out of our hat. That is literally just completing the square using the quadratic formula, right? So, quadratic formula, 8-9. This is our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. Now, when we look back at our quadratic equation, we see that there's an a and a b and a c value. I can just plug in those values and solve for my x's. Let's see what it looks like in real life, okay? So my a value is 1, my b value is 5, and my c value is negative 14. The first thing I want to do is identify my a, b, and c values. Then I can put them into the quadratic formula to solve. So I do that, reminding myself what my a, b, and c are. And I'm going to have negative b, which is 5, plus or minus the square root of b, which is 5 squared, minus 4 times a, which is 1, times times c, which is negative 14, all over 2 times a, which is 1. And now I have to do some math, right? I need to combine my like terms correctly. Doing my orders of operations, got to take care of inside the root bar, and inside that root bar, I need to follow the right things, right? So I'll get 25, I got to do that squared first. Then I get negative 4 times negative 14, which is positive 56, all over 2. That's getting really easy really fast, isn't it? Now I combine my like terms inside my root bar, which is 25 and 56 is 81. And we know the square root of 81 is 9. So then we have x equals negative 5 plus or minus 9 divided by 2. So that's two different equations. Negative 5 plus 9 divided by 2 and negative 5 minus 9 divided by 2. That gives us 4 over 2, which is 2. And it gives us negative 14 over 2, which is negative 7. So we get 2 and negative 7. I know this is a lot to take in. So let's do it again, right? This is where it gets handy. What happens when we have an a value? Well, before we had to divide it off, right? But now we can use the a value in the quadratic formula. We no longer have to isolate it and get rid of it. We don't have to divide everything by 2, giving us weird fractions, right? We can just use our value of a in our quadratic formula. I substitute in for my a, b, and c values. And then I simplify, right? Now again, remember inside your root bar, you need to do your exponents first. So it's 9, and then negative 4 times 2 is negative 8 times 5 is positive 40, right? Then the square root of 49 is 7. So we'll end up with negative 3 plus or minus 7 divided by 4, which gives us two equations. Negative 3 plus 7 divided by 4, and negative 3 plus negative 7 divided by 4. So we get negative 10 divided by 4, and 4 divided by 4. That gives you negative 5 over 2, or negative 2.5, and 1. What happens if I have something like this? Well, that's okay. There is just not, the b value is 0. Totally fine. And the c value is still negative 8, right? So we'll get negative 0 plus or minus 0 squared minus 4 times 2 divided by, times negative 8 all over 2 times 2. So we'll get 0 plus or minus 64 divided by 4. The square root of 64 is 8, so we'll end up with plus or minus 8 divided by 4. So we get positive 8 divided by 4 and negative 8 divided by 4, giving us negative 2 and 2. Pretty cool, huh? Go ahead and do this you try and check your answer. Okay, hopefully you identified your A as 1, your B as 5, and your C as negative 6. And when you plug it in, you would have gotten negative 6 and 1. Oh, we're going to skip this, sorry. This is not happening. You can actually ignore all this. Sorry about that. Cut. And we're going to move on. So, what happens here? I first need to put it into standard form, right? I subtract the 2x from both sides, and I get my x squared minus 2x minus 3. I'm going to identify my a, b, and c. That's 1, negative 2, and negative 3. And use my quadratic formula, just substituting into it. So x equals negative b, which is negative negative 2, which ends up with positive 2, plus or minus the square root of negative 2, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times 1. So a negative negative 2 is just going to be a positive 2, plus or minus 4 minus a negative 12, which is going to be adding 12. So we'll get 2 plus or minus the square root of 16 divided by 2. So plus or minus 4 divided by 2. So we'll have 2 plus 4 divided by 2 and 2 minus 4 divided by 2. Ending up with negative 1 and 3. All right, what happens when it's written like this again? First, put it in standard form, right? You could see if I completed the square, I'd have to cut 3 in half and then square it and add to both. That just gets messy. So this is why quadratic formula is so nice. You identify your a, b, and c, plug it into your formula, and solve. You just have to really watch your orders of operations to make sure you don't make a mistake. So now what happens when you have something like this that's not square rootable? 17 is a prime number. It's not square rootable. I can't reduce it at all. I can leave my answer like this, right? But if I want to graph it, I'm going to need to get the decimal for 17, right? Square root of 17. And then I would go from there. If I want to do that, it would be 4.12, and then I would add that and subtract it from negative 3 and divide by 2, right? So I'd just do some math. I'd get a half and negative 3.65. So Go ahead and try this one. Pause the video and then we'll check it. So my A value is 5, my B value is 7, my C value is -6. When I plug it into my quadratic formula, I should get square root of 169, which is 13. So I get -7 plus 13 divided by 10, and -7 minus 13 divided by 10. Or -20 divided by 10, and 6 divided by 10. So -2 and 3/5. Okay, for homework today, you have 2 puzzles that are on Learn, and you need to show your work on paper, okay? Show your work on paper. You'll have the rest of the class time to work on this, and I'll see you next time.